please review the basics in the textbook, because I believe that in Gen Chem, acid-base, different types of acid-base should be a major focus. So please review it briefly so that you can work on the problem. The homework problem should be straightforward by just using the equilibrium knowledge we reviewed, but still, please go ahead and read the basics about acid and base. And we talked about Kw, which is the product between hydronium ion and hydroxide ion, right? And you can see that there's a table that when the temperature is different, Kw could also be different. And the value we have been using, Kw equals to 1 times 10 to the negative 14, is by assuming it's 25 degrees. Okay? And you can see that at different temperature, the Kw can be changed. And another quick review on acid base is, do we know the difference between strong acid base and weak acid and base? Anyone? Strong dissociation. That's right. So strong acid and base will dissociate almost completely, but weak acid base only dissociate partially in the solution. And we will be talking about acid-base equilibrium later, but just to give you a review a little bit here for the homework, for an acid base, when we write the equilibrium, you can use 2 different forms. Okay, the first form is whatever the weak acid with water, it will be formed the hydronium ion, right, plus A minus. Okay. And what is Ka here? So Ka is the equilibrium constant for a weak acid, right? And it's basically the same formula with equilibrium constant. Again, like the KSP, we're giving it a specific name for it. And how do you write Ka for this case?
Hydronium concentration times the A minus concentration all over the HA.
Over the HA, okay. It's good. So we are not including H2O because it's a liquid, okay. You can also write it in a form, a more simple, a simpler form, which is H plus or A minus. So it's exactly the same thing. And in this case, Ka will be H plus, A minus, or HA, okay? And so in this case, what is the pair of conjugated acid and base?
Would it be HA and A minus?
Yes. HA and A minus is the conjugated acid and conjugated base. Now, if you have A minus to start with as a conjugate base, it's also a weak base. It will go through this reaction. Okay. And for this, we define it as Kb, which will be HA OH minus divided by A minus, okay? And you can see that if you multiply Ka by Kb, Ka by Kb, it will H3 plus A minus HA multiplied by HA OH minus and A minus. What will happen here? The A minus will cancel out, HA will cancel out, and you just get H3 plus and OH minus. And what is this? The product between the hydronium ion and the hydroxide. Yes, this is the Kw, okay? So for a conjugated acid and base, Kw is Ka multiplied by Kb. This is when we are considering a monoprotic acid and base, meaning that there's only one proton that can be dissociated from acid. But what if we have multiple protons? For example, we have this phosphoric acid. It has 3 protons that can be dissociated. So it's called polyprotic acid. And if you write the dissociation reactions for the polyprotic acid, you can write 3 steps, right? From the 3 protons losing 1, you have the 2 protons left. And the second step and the third step. And you can write Ka for every step. The first step is Ka1, then Ka2, and Ka3, okay? So you can see that relatively Ka1, the first step will have a higher equilibrium constant compared to the last step. It means that the last step is really hard to occur. The dissociation at the last step is very weak. And when you look at the conjugate base, starting from the phosphoric ion here, you can write the equation for the weak base case, right? And for each of them, we have Kb. So Kb1 is this, Kb2, and Kb3. All right. So now, what are the conjugate acid and base pairs for phosphoric acid case?
The H3PO4 and the H2PO4 minus.
That's right. So this one and this one, they are a conjugate pair. And anything else?
The H2PO4 minus and the HPO42 minus.
This one and this one, they're also conjugate.
And also in the last one without H plus.
Yes. So we actually have 3 pairs of conjugate acid and base, okay? And at the same time, if you're looking for Ka and Kb, you can see that these 2 are a pair. And these 2 are from a pair, and these 2, okay? So Kw is Ka1 multiplied by Kb3. It's also Ka2 multiplied by Kb2 and Ka3 multiplied by Kb1, okay? All right, so that's just